Hi, Dr. Besser. This is the outline for my interactive module. So I've selected the topic to be electrical circuits. And I've kind of selected three main points, trying to keep it pretty simple considering this is an intro topic for my junior and senior physics students. But the first thing that they will be doing is discovering the essentials to building an electric circuit that basically turns on a light bulb. It's kind of what is the minimal thing needed. So there's a really cool YouTube video at MIT and Harvard graduation where they give this to students graduating this task and just see which students can do it. So I'm going to use a YouTube video, kind of create an ed puzzle on it for the basics. And then I was also going to use, which is going to be a real common thing in the whole outline, is fet.colorado.edu, which is an interactive simulation online where they can build electrical circuits and actually use the multimeters. So the first thing I was going to do are just what are the key components. The kids would then be able to see me build that on fet.colorado.edu. And then within the ed puzzle, I'd be able to assess them on this. Obviously, a lot of the assessment for this will be at the end of the unit, through the unit, during labs, quizzes. I'll be able to assess them continually besides just on the website that I've chosen, obviously, through Weebly. So some of the subpoints right here, what are the materials needed? What are the major connecting points for the battery and light bulb? This is usually why kids struggle. And then one of the other main things is just creating a closed circuit with the materials that you're given. And in the video, it's kind of tough because they only give them one wire. So I'll first provide them that challenge, which will emphasize the major points, connecting points of the battery and light bulb. And then from that, when you give them two wires, it'll be, let's just create a closed circuit. And that should be pretty simple with multiple wires. So you can see that, again, it'll be consistent. I'm going to do a lot of screencast-o-matic with fet.colorado.edu, so I'll be able to show them how to build these circuits, how to use the multimeter. And then throughout, I can give them assessments either with Edpuzzle, Google Form quiz, and like I said, at the end of the unit. So that'll kind of be the YouTube video that I select, and that'll also be my video presentations. And then also, obviously, some of the assessments that I'll be using. To finish it up, though, the second learning objective, I want them to be able to correctly use the multimeter to measure current, voltage, and I'm going to include resistance on this as well, even though that's not a common thing we measure with the multimeters. It's still a nice thing to know to check your math if your resistance is correct. So again, through this, you can see I've got the same stuff, screencast-o-matic, fet.colorado. But the first sub point, at least, is how do you measure voltage? Then how do you measure resistance? And finally, how do you measure current? So it'll be pretty repetitive with at least, hey, we're going to pick up the multimeter. This is how you connect it to these devices. And I can show two of them, voltage and current, at least with fet.colorado. The other, I'll probably create my own video presentation. But same type of assessment, ed puzzle at the end of the unit, of course. And then the final learning objective that I chose, the three different types of major circuits, which is not a day one thing necessarily. That's something that we'll build to, and this kind of concludes the unit when we get to complex circuits. But they're going to be able to correctly identify the three types. So again, I'll go through videos where I build them. We'll kind of talk about what makes them that type of circuit, and also what are the pros and cons of those types of circuits. What I'm going to do differently for the assessment in this is I'm going to have them then in fet.colorado on their own create their own circuit, whichever one I've obviously chosen for them to build. They'll then take a screenshot, and we use Keynote since all the kids have iPads. So I'm going to have them then create a keynote presentation with these, and I'll be able to have them hand in that presentation, if you want to call it, through Keynote, where I can assess them on the three screenshots of their circuits, and then them kind of showing me necessary things that make it a series, parallel, or complex circuit. So subpoint one will be, let's just build the series circuit, and this one is obviously one with the single path for current to flow. Subpoint two, when it splits into multiple paths, this is a parallel circuit. And then finally, the most difficult of the three and kind of conclusion of the entire unit itself is what makes a complex circuit different from series and parallel circuits. It's actually a combination of both of them. Now, again, considering this is an intro website for them to use, I'm not really asking that complex of questions about these circuits, just can you determine which one is which and what makes it that? And this will, again, get them familiar with the the website with the simulation and just some questions that we will then be scaffolding into with these difficult circuits. So at the end, I put the resources, obviously. Weebly is going to be the way that I provide this interactive module for the kids. Within it, I'll be doing a lot of this stuff, even some external links that they can navigate to. So I feel like I have a pretty good grip on this outline. Please feel free to let me know if there's any drastic modifications you see that could be made. But thank you for your time, Dr. Besser.